Welcome, young mathematicians. Today, we're diving into a very important foundation of algebra, understanding monomials, binomials, and trinomials. Imagine sorting fruits in a basket. Apples, oranges, and bananas. Your basket could have only apples, or maybe apples and oranges, or apples, oranges, and bananas. Similarly, algebraic expressions can have one term, two terms, or three terms. A monomial is like having only apples. It's an expression with one term. For example, 7xy or 3z squared. Then comes the binomial, like having apples and oranges, containing exactly two unlike terms such as x plus y. Finally, trinomial is like apples, oranges, and bananas, together exactly three terms like x plus y plus 7. Remember, terms must be unlike. Combining like terms reduces their count. This classification helps us simplify and work with expressions effectively. Understanding these will build a strong base for simplifying expressions and solving equations ahead. Let's bring it all together. All monomials, binomials, and trinomials fall under the family of polynomials. Think of polynomials as a big umbrella that holds different expression types with one or more terms. A key idea when working with polynomials is like terms. What do you think like terms are? Simply put, these are terms that have the exact same variables raised to the same powers. For example, 15x and negative 21x are like terms because both have the variable x to the power 1. But 7x and 12y are not like terms since they have different variables. Understanding this difference helps us simplify expressions by combining like terms only. Remember, addition or subtraction of unlike terms is not possible directly. Imagine having different colored building blocks. You can only combine blocks of the same color to make a bigger block. That's exactly what like terms are for algebraic expressions. Let's learn by doing. Here are 7 pairs of algebraic terms. Your challenge is to decide which pairs are like terms and which are unlike terms. Start with pair 1, 7x and 12y. Notice that the variables are different, x and y. Since variables differ, these terms are not like terms and cannot be directly added or subtracted. Pair 2, 15x and negative 21x. Both share the same variable x to the power 1. These are like terms and can be combined by adding coefficients. Pair 3, negative 4ab and 7ba. At first glance, variables may look different order-wise, but remember, multiplication is commutative. AB equals BA. So, these have the same variables and are like terms. Pair 4, 3xy and 3x differ, since the first term has y and the second does not. They are unlike terms. Pair 5, 6xy squared and 9x squared y. The powers differ for x and y in the two terms. Hence, unlike terms. Pair 6, pq squared and negative 4pq squared have the same variables raised to the same powers, so they are like terms. Pair 7, mn squared, and 10man differ in powers on n. They are unlike terms. Can you try adding the coefficients of the like terms pairs? Pause and try it yourself. Confident? Great. Let's verify together. Let's now verify your answers. Reviewing each pair, pair 1 has different variables, so they are unlike and cannot be combined. For pair 2, since both are x, add their coefficients. 15 plus negative 21 equals negative 6. Thus, the combined term is negative 6x. Pair 3, remember multiplication is commutative, so AB and BA are the same variables. Adding coefficients, negative 4 plus 7 equals 3, so result is 3AB. Pair 4 has an additional variable, y in the first term, so it's unlike. Pair 5 has different variable powers, xy squared versus x squared y, so unlike terms. Pair 6 are like terms since variables and powers match. Adding coefficients 1 and -4 gives -3, so combined term is -3pq squared. Pair 7 has different powers of n, so unlike. This table on screen clearly summarizes these results for better understanding. By mastering identification of like and unlike terms, you can simplify algebraic expressions accurately and confidently. To simplify algebraic expressions, accurately identifying like terms is crucial. Here are 3 simple steps to help you decide whether terms are like or unlike. First, ignore the numerical coefficients. For example, in 3x and 7x, we focus on the x part only. Second, check whether the variables themselves are the same. If the variables differ, such as x and y, then the terms are unlike. Third, check if the powers of each variable are the same. For example, x squared and x cubed are different due to powers. Remember, numerical coefficients don't affect classification. Also, the order of variables in multiplication does not matter. AB is the same as BA. When terms satisfy these steps, they are like terms and can be combined with simple addition or subtraction by working with their coefficients. Practicing these steps will make your algebra life much easier when simplifying expressions. Now let's switch gears and talk about evaluating algebraic expressions. You can think of algebraic expressions as machines that take a number input for each variable and give a numerical output. The value of the expression depends entirely on the values you plug in for the variables. For example, in geometry, the area of a square is given by L squared, where L is the length of a side. If L equals 5 centimeters, then the area is 5 squared, which is 25 square centimeters. Why is this useful? Sometimes you need to check if a particular number satisfies an equation. Plugging in the value lets you verify if the equation balances. Other times, formulas use variables to represent real-world quantities. Substituting the given values helps find practical answers. For each problem, substitute values carefully and follow order of operations. Keep in mind, this is like opening a secret box. Put in numbers and see the magical result. Ready to try evaluating some expressions? Let's work together to evaluate expressions for x equals 2. Here are 4 expressions we'll find the values of. First, x plus 4. We substitute x with 2, so 2 plus 4 equals 6. Next, 4x minus 3. Substituting gives 4 times 2 minus 3, which is 8 minus 3, which is 5, 3, equals 5. Third, 19 minus 5, x squared. Substitute x with 2, square 2 to get 4. Then multiply 5 by 4 to get 20. So 19 minus 20 equals -1. Finally, 100 minus 10x cubed. Cube 2 to get 8. Multiply 10 by 8 equals 80. So 100 minus 80 equals 20. By substituting carefully and following the order of operations, you can find the value of such expressions confidently. Ready? Let's verify these together. Let's validate each substitution step by step. In the first example, we substitute x with 2. That gives 2 plus 4 equals 6. In the second example, 4 times 2 equals 8. Then subtract 3 to get 5. In the third example, square 2 to get 4. Multiply by 5 to get 20. Subtract from 19 to get -1. In the fourth example, cube 2 to get 8. Multiply by 10 to get 80. Subtract from 100 to get 20. Did you get the same results? This method is straightforward. Substitute the values. Perform powers first, that is exponents. Then do multiplication. Finally, Do subtraction or addition accordingly. Try these steps on your own with different values now. Let's analyze and solve these expressions for n equals -2. First, 5 times n minus 2. Substituting n with -2 gives us 5 times -2 minus 2. That is -10 minus 2, which totals -12. Next, 5 times n squared plus 5 times n minus 2. We already know 5 times n minus 2 is -12. So now we just need the value of 5 times n squared. The square of -2 is +4. Multiplied by 5 yields 20. Adding these together gives 20 plus -12 equals 8. Finally, n cubed plus 5 times n squared plus 5 times n minus 2. The last three terms sum to 8, as we just found. Now, the cube of -2 is -8. Adding this to 8 yields 0. Great! The last expression evaluates to 0, meaning n equals -2 is the root of the polynomial n cubed plus 5 times n squared plus 5 times n minus 2. Notice how powers affect positive and negative values. Negative squared becomes positive, but negative cubed stays negative. Keep practicing substitutions to develop your intuition. Let's carefully review each computation. For the first one, multiply 5 by -2, which gives -10. Then subtract 2 to get -12. For the second one, the square of -2 is 4. Multiply that by 5, which equals 20. Then add 5 times -2, which is -10. Finally, subtract 2. So, 20 minus 10 minus 2 equals 8. For the third one, the cube of -2 is -8. Add the result 8 from the previous step, which totals 0. This 0 value shows that n equals -2 is a root of the expression. This means it satisfies n cubed plus 5, n squared plus 5, n minus 2 equals 0. Remember, stepwise substitution and calculation help avoid mistakes. Always work through powers first, then multiplication, and finally addition or subtraction. Let's evaluate expressions involving two variables. Suppose a equals 3 and b equals 2. For the first expression, a plus b, substitute to get 3 plus 2, which equals 5. In the second expression, 7a minus 4b becomes 7 times 3, minus 4 times 2. This equals 21 minus 8, or 13. The third expression is a squared plus 2, ab plus b squared. This is the perfect square expansion of open bracket, a plus b close bracket squared. Let's calculate each term. 3 squared equals 9. Plus 2 times 3 times 2 equals 12. Plus 2 squared equals 4. Adding 9, 12, and 4 gives 25. Finally, the fourth expression is a cubed minus b cubed. This is 3 cubed minus 2 cubed, which equals 27 minus 8, or 19. Substituting variable values inside expressions allows you to find precise values, which are useful in real-world applications and problem solving. Let's review the detailed steps for each expression to ensure clear understanding. Expression 1. Adding a and b values directly. 3 plus 2 equals 5. Expression 2. Multiply and subtract. 7 times 3 equals 21. 4 times 2 equals 8. Subtract to get 13. Expression 3. Evaluate squares and product. 3 squared is 9. Twice 3 times 2 equals 12. 2 squared is 4. Sum these to get 25. Expression 4. Cube subtracted. 3 cubed equals 27. 2 cubed equals 8. Subtraction yields 19. By following each step carefully, you'll avoid common pitfalls and strengthen your problem-solving skills with algebraic expressions involving variables. Let's put your knowledge to the test with some practice exercises. First, classify a series of algebraic expressions into monomials, binomials, or trinomials. Remember to look carefully for the number of unlike terms. Next, evaluate given expressions by substituting specific variable values. This is a great way to practice calculating expressions involving multiple variables. Lastly, identify like terms within a group, observing variables and powers. Take a moment to attempt these questions on your own. When you're ready, review your answers carefully or discuss with friends or a mentor. Mathematics is a journey. Practicing these fundamentals gives you a strong map to explore more complex algebra ahead. Let's wrap up today's exciting exploration into algebraic expressions. We learned classification of expressions as monomials, binomials, and trinomials, all under the polynomial family. Recognizing like terms based on variables and powers is essential for combining terms and simplifying expressions. Being able to substitute and evaluate expressions with given variable values is crucial in both pure and applied mathematics, from geometry formulas to physics calculations. Mastering these foundational ideas sets the stage and builds confidence for more advanced topics, such as factoring polynomials, understanding functions, and even the calculus world. Remember, every mathematician started here, understanding the language of algebra. Keep practicing and stay curious. Math is your superpower.